So now let's go to the computations involving titration data. So now you will slowly see, you will connect the previous discussions we had as to how titration allows us to determine the concentration of the analyte. So let's consider we have 25 ml of a certain hydrochloric acid solution. So we don't know the concentration of HCl in this solution. And we have a titrant with a specific concentration, 0.1 molar sodium hydroxide. Of course, we need our indicator. So the indicator must be present in our analyte. So we add several drops of phenolphthalein solution into our analyte. Let's say we needed 50 ml of this titrant for the solution to turn pink. So what does this mean if the solution turns pink? It means we reached the endpoint. Again, the endpoint is the signal, the visible signal for the equivalence point. So now that we are at the endpoint, we stopped adding sodium hydroxide solution. Now we apply the definition of titration. Again, titration, the definition of equivalence point. Equivalence point means the amount of base added to our analyte. Well, in this case, our titrant is basic. So the amount of base added to our analyte is stoichiometrically equivalent to the amount of our analyte. So we know that our analyte is the acid. Okay, it's a H plus ions essentially. Again, we have the neutralization reaction as our basis. So your hydrogen ions react with hydroxide ions in a 1:1 ratio. Now, given this information, we can get the moles of base used until we reach the equivalence point. And that is 50 ml. So we convert this to liter times the concentration of our base. This will give us the amount of base used until equivalence point. Now, we can relate this to the amount of acid in our solution, in our analyte, right? How is that? If this is the amount of base used, and we see that OH minus is reacting with H plus ion in a 1:1 manner, then the moles of hydrogen ions is simply equal to the moles of the hydroxide ions added. So now we can compute for the concentration of the acid in our analyte because we have the moles of hydroxide ions. So that's 50 ml or 0.050 liter times 0.1 molar, which is the concentration of the base. And we divide this by the volume of our analyte, which is 25 ml or 0.025 liter. So this will give us a concentration of 0.2 molar. So titration, again, we see here, it allows us to determine the concentration of a certain analyte. Now, what about characterizing or identifying the substance found in our sample? You will learn that in the next video.